Hello guys, we have seen theory for 2D arrays in the last session. Now let's implement some code so that we will cross check the things that we have seen in the theory part. So here I declare one 2D array int arr 3 by 3 and I initialize that 1, 2, 3, 4, 5, 6, 7. I am initializing only first 7 values. So this code will get compiled. If I compile it, let me try to compile it. GCC, then name of the file is arrays.c -o, say executable is arrays. So it will get compiled because this is called as partial initialization. If I initialize only few elements of the array, then it is partial initialization, and in that case rest of the elements are initialized to 0 automatically. So I will print few printf statements. First I will print arr, then I will print ampersand arr, asterisk arr and asterisk arr. So here it is ampersand arr, asterisk arr and asterisk arr. Let me copy paste these 4 lines and let me add 1 to each of them. So arr plus 1, ampersand arr plus 1, asterisk arr plus 1 and asterisk arr plus 1. So here it will be plus 1 everywhere. So I am printing these 8 values. So let me compile and run it. It is compiled /arrays. So these are the outputs. Now let me cross check them with the outputs that we have seen in the theory part. So I have kept the screenshot here. So you can see that arr, ampersand arr and asterisk arr, all of these 3 values are same. So here also if I see arr, ampersand arr and asterisk arr, output is same. It is some address ending with 748. After that, asterisk arr is 1. So here also asterisk arr is 1. Then we will observe the difference between arr and arr plus 1. So if you see the difference between arr and arr plus 1, here it is 748 and 760. So difference is 12 bytes. In this diagram also the difference is 12 bytes between arr and arr plus 1, 1000 and 1012. Then difference between ampersand arr and ampersand arr plus 1 is 36 bytes, 748 and 784. So 36 bytes of difference. Here also it is 1000 and 1036. Then difference between asterisk arr and asterisk arr plus 1 is 4 bytes, 748 and 752. So same is here, 4 bytes difference. And between asterisk arr and asterisk arr plus 1, the difference is of value 1. 1 and 2 are the values and difference is 1. So that is okay. Now let me print, suppose this value also. Suppose I write printf %u. I am printing arr of 1 here. And I am also printing asterisk arr plus 1. It is a 2D array. Still I am accessing that as a 1D array. And let me check. So this is the subscript notation to access the elements of 1D array, and this is the subscript notation, pointer notation to access the elements of 1D array. So if I use these notations, then whether it will get compiled. So for that I will try to compile this code. Yes, it is not throwing any error. Here it is getting compiled. So though it is a 2D array, I can access the elements of that as 1D array notation, using 1D array notation. So let me check what is the output in that case. So here for last 2 values, okay, let me write \n for last 2 values, it is printing some address which is same. Now why it is same? Because you know that for ARR plus 1, the corresponding pointer notation is asterisk ARR plus 1. So it is some address. So it is address of which thing? So if you see this diagram, it is address of first 1D array. Now 2D array is I told you that 2D array is an array of 1D array. So when I say ARR of 1, the first element of that 2D array, which is nothing but this 1D array containing 4, 5, 6 values, the address of that will get print. So 72 is the output. 472 at the end is the output, which is same as this address. So this was all about the 2D arrays. Thanks for watching the video. Please do subscribe to my channel. We will see you again in the next video.